Hey guys, in this video, I'll show you how to install Frigate on Proxmox as a VM with SR-IOV and how to upgrade an existing Frigate LXC container to use SR-IOV. This setup allows you to share the GPU between VMs and LXC containers at the same time. Whether you're starting fresh or upgrading your current setup, this video got you covered. We'll also stream your live CCTV footage to both non-smart and smart TVs. And finally, we'll install Netbird so you can access Frigate from outside your home, even without port forwarding or a public IP. In my previous video about adding a desktop environment to an LXC container, I mentioned that you cannot share a GPU between a VM and an LXC. That's because the VM typically tries to take full control of the GPU, leaving LXC containers unable to render graphics. That's why some people opt for LXC containers only, because you can share the graphics card with other LXC containers, but this is only for the case if we're not utilizing any hardware feature. There's a way to use the GPU on both VM and LXC, and that's with SRIOV, or single root I/O virtualization. Instead of using the GPU directly, the driver will split the GPU into 7 virtual functions, and each VF can be passed individually to VM or LXC containers. That means we can install Frigate as a VM or as an LXC, while being able to install other virtual machines or LXC containers, without the hassle of being restricted to only a single GPU. Windows VMs, Linux distro VMs, and headless LXC containers. With this hardware feature, it opens new doors on what we can do with Proxmox. The first thing we need to do is go over the guide from Derek Seaman and copy the Proxmox kernel configuration in order. We will install build tools and build the SR-IOV driver. Make sure you're using at least kernel 14 or 11 for full GPU compatibility. Copy the command from step 3 and it will take a few minutes building the driver. You'll only need to follow step 4 if you're not using secure boot. Otherwise, run the command if you require secure boot. Now, when copying for grub configuration, you can copy the first command if you're not using the Coral TPU. For VMs, you can copy the second command to isolate the TPU on a single virtual machine. If you change your mind on this, we can also show you how to undo this later. I skipped the system deboot step since Proxmox uses grub by default, and also skipped mock key enrollment as it's only needed for secure boot. Then, I moved to step 5 to check the GPU. If you see a message showing SR-IOV mode with 7 VFs, the GPU is working and we can proceed with the VM container. In terms of ISO for the VM, I downloaded the latest ISO from Debian and I selected download from URL, wherein I pasted the download link of the ISO file and copied the same file name below the file name box. Afterwards, I started to create the VM via Create VM on the top right. I named it Frigate VM and enabled advanced settings. For ISO image, I selected the Debian ISO and went next. For graphics card, select default for now, set the machine to Q35 and enable QEMU agent. For BIOS, select OVMF and select your EFI storage. For non-secure boot, make sure pre-enroll keys is disabled. Otherwise, enable it if you're using secure boot. For this, you can assign your disk size here and also set your cache to write through. Also, enable disk card if you're using an SSD drive. As for the CPU, I only use 2 cores and the type is set to host. For the memory, set your memory with 8GB and minimum memory with 2GB. Also, keep ballooning device enabled. For the network, let it by default and we can now proceed to the hardware. First, add a PCI device. Select raw device and choose a VF GPU. Only select between 1 and 7. Enable primary GPU and PCI Express under Advanced Options. For the Coral TPU, also select Raw Device, choose Coral Edge TPU, and enable PCI Express. Now, we can add a serial port and keep it to 0. This is for connection with the terminal later. Next, we will need to edit the display and add memory. I've set it to 256 megabytes. Once done, we can now start the VM container and start with the installation. Select Graphical Install and proceed with your desired language and country. Afterwards, add your host name, domain name, and user credentials. For partition, I went with guided use entire disk. Then, I selected all files in one partition. And finally, I selected yes on write changes to disk. After that, I selected no when prompted to scan for additional media and chose the closest country for the package manager. It will take a few more minutes to finalize. For software selection, uncheck GNOME and desktop environment, as we only need a headless install. Once the installation is complete, we're ready to set up the serial terminal. Log in as root, and from here, you can either go to the Chrome Web Store and download VM Console extension for an easy way to copy and paste text, or set up the serial terminal, which allows native copy-paste without needing an extension. Simply edit grub and copy the lines from Proxmox documentation on Serial Monitor. We will need this so that we can properly use Serial Terminal. Just paste this into the command line Linux default and save and exit once done. Run update grub and reboot once completed. From console on the top right, we can select xterm.js for Serial Terminal. It will open a new window and we need to press enter once to show login. Login is root again and we can proceed with the driver installation. The first thing we need to do is update the kernel. By default, Debian uses 6.1. We will need to use a bleeding edge kernel for SR-IOV. I follow the guide from FOSS-Tips to get the latest kernel. First, install curl and GNU PG. Then, you can copy the commands in step 1. For step 2, the guide has a typo. The fixed command will be in the description. Once done, you can run apt update and we can now install the zabbly kernel. It will always install the latest kernel from its directory. Once it's complete, do a reboot and we can proceed to the SR-IOV driver installation. In step 1, all we need to do is install the build tools and DKMS, since we have already taken care of the kernel and headers. Copy the commands from step 2 to install the driver. This will take a few minutes. After that, we can edit grub again and add additional parameters for SR-IOV. Simply copy the values from step 3, save and exit, then update grub. Instead of rebooting, we will perform a shutdown. At this point, we no longer need the display, so set it to none. This ensures the VM doesn't create a virtual GPU for display, but instead uses the VF GPU directly. Log in as usual, and if you copy and run the command from step 5, you'll see the same message confirming that we're running in SR-IOV VF mode. Additionally, we've blacklisted the XE driver. If you try to install VA Info and tried running it, it will not work, as GPU stats are not available in VM. However, we can see this in LXC containers. We will cover how to get the GPU stats for those who want to upgrade their LXC with SR-IOV. Now, we will proceed to installing the Coral TPU. First, I copied the first command and removed sudo. Then, I installed the runtime packages. I copied and removed sudo in the command in step 3, for root and for the user. We removed the gasket driver, installed git, dev scripts, and DHDKMS. In my previous video, I showed how to manually build this for 6.14. A faster way to do this is to use a fork instead. We will clone the fork from Viper Dave, who also gave a very good explanation to the modifications. This is based from the commands from lilobzh, just modified for kernel 6.14 and above. After cloning, cd to the gasket driver directory and run the dbuild command to start building the driver. Once done, cd back to home, and now you can install the Debian package. Run an apt update and upgrade and reboot once completed. Once you've logged in, run ls/dev, and once you can see the directory of the drive folder for the GPU and the Apex 0 for the Coral TPU, we can proceed with installing Frigate. First, we will install Docker. Copy and run the AP repository in step 1, then install the Docker packages in step 2. I will install Frigate in /op, create a directory, and inside the Frigate folder, create a directory for the config file. We will create the Docker compose file with nano. Make sure to prepare your Docker compose file. You can find this in the Frigate documentation. I removed the comments on Apex and render. Make sure these are enabled so that Frigate will use the devices properly. Once you're done, save and exit and cd to the config directory, as we will also nano our config file. You'll also need to prepare your Frigate configuration, which is covered in the documentation. As long as you can confirm that you have a functional RTSP link, you can create your config file. Simply copy and paste your configuration, then save and exit once you're done. cd back into the main Frigate directory, and now you can run docker compose to start Frigate. Get the VM's local IP and navigate to the website with port 5000. And now, we have Frigate installed. However, do take note for VMs you can't see the GPU stats. You'll see a PMU support error. If you really need to verify the GPU is working, you will need to run Intel GPU top with SR-IOV on host. In case you want to still use Frigate in your LXC container, we can also pass our VF GPU inside our container. We will follow the guide from Saito. The first thing I did is to copy and run the usermod command from create container. Once done, I proceeded to shut down the LXC container. We're going to edit the LXC configuration. Navigate back to shell and edit the LXC config with nano. To make things easier, the full configuration will be in the description. I modified the LXC configuration multiple times in order to find the correct configuration of the GPU, and also to be able to see the statistics. With the full config, we're pretty much ready and need to edit the config once. In my first edit, I essentially added the passthrough of the GPU. If you see in the picture, we're essentially adding 4 lines. From the example, the first line is basically saying that you're allowing card 6 with permissions. How do I know it's card 6? The number after 226. In the second line, notice there's 2 paths. The first path is basically the VF card going to be used by the LXC container. You should only choose between 1 to 7 and never 0, as that will cause software crashes or errors. The second path is the identity of the first path inside the LXC container. In the example, you're essentially saying card 6 is going to be card 0 inside the LXC container. And the same idea goes for the third and fourth line. The third line is allowing render D134, and the fourth line is basically render D134 is taking the identity of render D128 inside the LXC container. You can also opt for the same paths. For example, you use render D129 in both first and second path. That's also valid, but you'll need to modify the Docker Compose file and change it to that specific render path. In the video, I used card 1 and render D129. For grub configuration, you'd want to use the first command from the Derek Seaman guide, or you can copy like mine on screen. Once edited, update grub and init ramfs. An optional way to view GPU statistics in Frigate while using SR-IOV mode is to update Frigate to version 0.16 beta free. This version includes optimizations for reading GPU data inside an LXC container. After editing your configuration, simply run Docker Compose down followed by Docker Compose up to pull the latest update and start Frigate. Additionally, I ran modprobe MSR. Then, edited the LXC config file to add the necessary pass-through lines for the CPU. After that, I perform a reboot. Next, I changed the perf event paranoid value to 1 and made the change persistent across reboots. Next, I modified the LXC config file again to add the perfmon line and restarted the LXC container. Then, I modified the Docker Compose file again and added the sysadmin, ptrace, and perfmon. After that, I ran Docker Compose down and Docker Compose up. Once that's all done, final step is to add the following lines to your Frigate configuration. You can copy and paste them directly into the config file and restart Frigate once you're finished. If you check the system logs afterward, the PMU error should be gone and GPU statistics should now be visible. For non-smart TVs, if you have a single board computer lying around, you can install Kodi and play your live Frigate footage. Head over to LibreElec and download the latest image file for your specific PC. For flashing the image, I use Balena Etcher. Next, you'll need to set up a site where you can host your M3U file. This file is essentially a playlist that contains your stream URLs. For example, I use Codebird, but you can also host it locally or any online platform. The M3U file follows a basic format, with the logo and title listed first, followed by the RTSP link. A sample copy will be included in the guide. Once you've started Kodi, go to Add-ons and select Install from Repository. From there, navigate to All Repositories. Then, go to PVR Client and install IPTV Simple Client. After the installation, select Configure, then edit Migrated Add-on Config. Under the General section, since I'm using a link, I'll leave it to set to Remote Path. Then, in the Playlist URL field, I'll enter the raw link to my M3U file. Next, we will head over to the Kodi repository. Select Program Add-ons. We're going to look for IPTV Manager and install it. For settings, head over to Player. Make sure DRM Prime is enabled, along with hardware acceleration. This ensures the GPU is being used. For interface, go to Startup and set up your startup window on TV channels and perform on startup on Play TV, so that after you start the system, it will go directly to your live Frigate stream. And for the system, use your TV resolution and go for 60 FPS. I also use 1080 for the resolution limit and use free buffers for the GPU. In case you get video artifacting, you would need to do trial and error within the player and display. Once we've completed configuring Kodi, we can head over to TV and select Frigate channel. What's great about Kodi is that you can amplify the audio level in case if the default volume is very low. And with the startup setting, we've essentially made it very easy to watch our live footage in our TV. For smart TVs, you can also do this via the Viewed App Store. Just look for the SSIP TV app. Essentially, you will also need to create an M3U playlist like we did earlier with Kodi. Just enter the app and go to the settings in the top right. Go to Content and make sure you're in External Playlists. All you need to do is give it any name in the title and provide your personal M3U link in the text box. Once you're done, hit Save on the top right, and we can now access the playlist in the main screen. In my experience, it has some delay about 5 to 10 seconds, but it can also vary for each TV. As for settings, I've only added time to it and there's not much to do, but this solution is for smart TVs that aren't using Android TV. If you want to use Frigate outside, you can install Netbird. All you need to do is create an account and install it. For VMs, simply run the install script command, and once that's finished, run Netbird up. It will give you a URL to add the VM to your Netbird network. Log into your account to link it. Then, go to the Netbird Peers dashboard, select the VM, view details, and disable session expiration. If you're using an LXC container, you can copy the helper script command and run this in shell instead. Select your LXC container and wait for a few minutes. Once done, reboot your LXC container, and once you're logged in, run Netbird up. It will provide you with a link with a code. Confirm this by logging into your account or creating an account. It says we're all set, but we still need to configure it inside of Netbird Peers. Select View Details onto the device we recently added. In here, you only want to disable session expiration and save changes once done. If you want to view this in your smartphone outside, you'll also need the app and manually logging it into your account. You can download this in the Play Store or via Aurora Store. I'm using Graphene OS and Netbird works here. You only need to do a small trick. Go to VPN and go to its settings. You want to turn off both always on VPN and block connections. You won't be able to log into Netbird with these enabled in your first open. Just open the app and hit enable. To access Frigate, just hold press the LXC container link and it will be copied, and paste this link to your browser. Don't forget to add the HTTP and the port number, and after that, you can access Frigate outside. To save this, just go on the top right options and select Add to Home Screen. This will allow you to open Frigate on your home screen. Remember, always connect to Netbird before going to Frigate. If you want to connect other type of devices outside, just install Netbird, add the device to the network, and navigate to your Frigate address and port. If you found this video helpful, make sure to give it a like and don't forget to subscribe to support the channel. Thank you guys for watching, and I'll see you next time.